Hi, everyone, and thanks for joining us for this session on AI productivity versus privacy. A look at the big gains and big trade-offs that will come with increasing use of AI-driven automation in the workplace. Technology has long been a key, perhaps the key driver for increased productivity, cutting costs and time, improving quality. There have also always been downsides, most often in the form of lost or reskilled jobs. Look at agriculture or manufacturing. One farmer in a computerized satellite-guided tractor today does the job of dozens, if not hundreds, of farm laborers 100 years ago. A similar story is true for automated assembly lines. This narrative, in which machines replaced human workers, has been the dominant one around automation in the workplace for years. But I think this session will highlight a different trend, and it's a trend that I think not everyone expected. Human jobs are certainly being automated, but instead of humans being replaced by automation, they're merging with it, becoming part of a hybrid human-machine workforce. Chief among the technologies making this possible is computer vision, backed by machine learning algorithms that are trained to identify, track, and analyze movements made by human workers. In this way, companies can access detailed data about human employees that was once only available for purely digital systems. We have a couple of speakers coming up who will tell us about two different ways that AI and computer vision are making it possible to bring this data-driven digital analytics to physical, human workforces. Prasad Akella, CEO of Drishti, will talk to us about his company's machine vision technology, which works alongside human workers in factories, spotting errors and finding ways to improve workflow. Then Arun Nair, CTO of Retail Next, will tell us how his company is using machine vision in bricks and mortar stores to watch the comings and goings of customers and employees to gain insights and make predictions about how efficiently the store is being run. I think both these companies are a sign of what's to come. Few would disagree that automation is the path to productivity, but robots are not yet widespread. They're simply not as versatile or creative as people. So if you want to automate the workflow in a store or factory, one option may be to use that automation to augment your human staff. But this immediately raises ethical questions. You cannot augment without monitoring and analyzing. The flip side to supercharged employees is workplace surveillance. Technology can be dehumanizing as well as empowering. We got a stark illustration of this earlier this year from Amazon workers who complained that excessive round-the-clock, on-the-job surveillance, including inflexible schedules and targets set and tracked by apps, stripped them of autonomy, treating them like replaceable parts of a machine rather than valued human staff. How much privacy is it reasonable to expect employees to give up to provide a better product or service? That's one of the poll questions for this session. But I don't think there's an easy answer. Many would argue that a certain loss of privacy has always been part of the deal sealed between employer and employee. But new technologies push this arrangement in new directions, broadening the scope and narrowing the focus of what tech can do. Our speakers will share not only what their novel tech does, but also, just as important, their thoughts on how to use such tech in the right way, and indeed, what they think that right way even is. I'm thrilled to introduce my first guest, Prasad Akella. Prasad is founder and CEO of Drishti, a company that uses AI-powered computer vision to closely monitor work done by human employees in places like factories or warehouses. The idea is to augment a human workforce with the kind of analytics previously only available to fully automated or digital systems. Prasad has long recognized the potential in hybrid technology that combines the creativity and flexibility of humans with the analytical power of computers. In the 1990s, when working at General Motors, he led the development of smart digital assistants called cobots, or collaborative robots. The idea of human and robot collaboration is now a large industry in itself, one that Prasad hopes to push forward once again with Drishti. Prasad, welcome to Emtech Next.
Thank you so much, Will. It's such a pleasure to be here today, talking about computer vision and its future as we look out and how we change industries with that. I was also struck by the comments that were made in the last session where Suzanne talked about the physical and the virtual and about creating data. Quality data, I think is what she called it, at scale using AI. And Easton's work on human hands brought back memories from 30 years ago when I was a PhD student, because my own PhD thesis was on robotic hands. And finally, I think Elizabeth hit a very central question, which is how do you keep people at the center of everything? Because I think fundamentally it is people at the center. So with that, I think what I'm going to do is just step into this and have a good time here with everybody. So let's talk about AI, computer vision, and what's coming up. We've seen for 50 years that we've been focused on object detection and fault inspection. That's how we've used computer vision. And what I'm going to be talking today is about looking at video streams and extracting information from the video stream to empower human beings so we can do our jobs better. This is not unlike a spell checker on your email or a grammar checker that makes you more efficient, but you're still the author of the work. Now, if I look at this in the context of the real world, I think there are two things the two basic myths that we deal with. The first is that it's robots that make things happen, that build the cars and the phones that you and I use. And the shocking fact is that people are really the ones who are making this happen, from America to China and across the globe. And what's more shocking is that we have no idea what's going on in these manual lines. Just think about the product recalls we deal with, whether it's a cell phone blowing up in your pocket or an airbag that deploys unexpectedly. It's these kinds of things that we need to figure out, make them efficient, help build them better, that we're focused on. And the second part of the second myth that we deal with is this myth of essentially the primary path to productivity is through automation. The belief that people are already optimized, and the only way forward is this notion of swapping the human with a robot. So I just want to put some numbers in front of you to just give you a sense of where we are. I referenced Easton's work on robotic hands. The work I did 30 years ago still hasn't made any entry on the plant floor. So that gives you one sense of time. The second is simple numbers. There's about 345 million people around the world on production lines. We produce about 350,000 robots a year globally. And so when you take all these numbers together, there are about 2.7 million robots deployed across the globe today. So when you take these numbers, we're looking at about a 0.5% penetration with robots, which means we've got another 100 plus years to go before robots really take over all of our jobs. And so that the message I have for you is that it's humans who build stuff and humans aren't going anywhere. So probably the primary path is to optimize what we do, even as automation makes its way along. So with that in mind, it turns out we've got to sort out two main issues on the journey to empowerment. The first is the measurement problem, because we've got to automatically figure out what's happening on the floor. We've got to get data so we can actually improve, because we can't improve what we can't measure. And that's centrally what Drishti has done. As I said, we've created a new technology called action recognition that parses the video. Not very different than Siri parsing the audio stream to figure out what is being said. We extract information from that video. And as you can imagine, doing this is incredibly harder than trying to do with audio alone. But by tying the extracted information and the raw video signals, we suddenly have deep insights into what's happening on the floor. Now, what we've chosen to do, the second step in this process, is to use the data to solve real-world problems. And we've applied it to probably one of the oldest industries out there, manufacturing, which is 15% of GDP, something like $12 trillion. And to give you some context, think about the fact that 113 years after Henry Ford and the Model T, we're still gathering data on manual lines using humans and stopwatches, nothing different from when he was on the floor. Now, imagine what you can do if you can change this. And instead of imagining that, what I want to do now is share with you a real-world example of using this action recognition to measure cycles, to see what individuals are happening and to do this at every single station on the plant floor at scale to create a baseline data set that's never existed before. So what you're seeing here is us processing our AI on a line producing engines somewhere in the world. We produce it on every engine, on every step in that engine. So suddenly now you have the ability to look at this data, to synthesize it, and to focus on what is actionable. and to focus on the small set of issues so that we can take our scarce resources, industrial engineering resources, production resources, quality resources, to solve what matters. And the results are pretty dramatic. Something like 11% increase in productivity, 30% reduction in defects. Remember, you're dealing with these companies producing single parts per million defect rates, and reducing them by 30% is dramatic. 15% reduction in scrap rates, making Kaizen events happen in half the time. And even something simple as figuring out, tracing back to see what happened when a customer reports an issue can be done in seconds and with tens of thousands of dollars less than it took before. So these are industry-changing results that put people in the driver's seat, that let higher wage countries compete on efficiency and technology. And it actually makes people work with technology as opposed to replacing them, just fundamental shifts. And so to talk about these fundamental shifts, I thought I'd sort of take three little examples of how I think of the world and how it changes. So the first is to think about the usage of data, and to sort of incent that conversation, to set that conversation up. I'm thinking about doctors that you and I visit, particularly in this time of COVID, is you want to actually present this the insights, you want to make them usable to a broad population. So there are two examples in this little picture here. The first is doctors start with stethoscopes, increase the complexity to an ultrasound if required, and then get to an MRI. So the diagnostics is going up, even as the sophistication of the technology is. Drishti does the same thing. You can get visibility to what's happening on the plant floor sitting in the comfort of your COVID home office without even getting out of your house. We can give AI-generated cycle time information that gives you a sense of how stable your line is running and how well it's running. And the third, we can give you analytics into critical process steps so you know that you're building a quality product. Again, increasing sophistication, increasing value. The second is from a user's perspective. Remember, our colleagues in the plant floor aren't exactly PhDs. They're not, we know it takes a PhD to design an MRI machine, but we need to set this up so a lab technician can use it. And that's fundamentally where we are going with all of this, which is we're trying to make sure that it's utterly simple and usable. The second big shift is in things like taking this data and putting on the floor is in a system like a Pokeyoke system. My customers complain to me that these Pokeyoke systems are increasingly looking like Rube Goldberg-like devices. So the beauty of what vision does, what we're doing here, talking about with computer vision and AI, is the ability to systematically, across the entire line and plant, generate programmable systems that generate this data and make it actionable in very short order. Just the scale at which we can function shifts when we can go from one-off systems to entire programmatic systems. And the third example I want to put into you, this is a massive shift is how do you drive structured problem solving using data that we are creating? So essentially now we are moving from small data sets, biased data sets, inaccurate data sets, to very large, accurate, unbiased data sets, which change the focus from gathering data to actually interpreting data, synthesizing the right types of insights, and actually taking action. And this means we got to show people on the floor we got to help them think from a data perspective, statistically, to understand how to use it. And I think that's going to be a massive shift, even something as fundamental as lean technology, lean methods, and lean production. But the idea is to problem solve on the plant floor with facts. And I just think this is going to provide a sea change in where we are going with all of this. So now, if I think about what is the future of the world, I think about I think about where we are going with all of this technology, and stepping back and thinking about it, we're really going to go to warehousing and distribution, to food services, to healthcare and pharmacy, making sure the pharmacist delivers the right product, and to retail. Now, this is massively important. People are working all over the place and recognizing what we're doing. And I think we have an opportunity to use AI and technology to start to completely radically shift where we're going. So, Will, I'm hoping that I gave people a sense of where we are, and love to take the questions that we have here.
Thanks so much. I mean, your vision of the future, I think, is the right one. But there's obviously loads of issues that we can get into in discussing that. Now, I just want to ask you, like, when I was Googling your company name, I noticed that drishti is also a yoga term that means sort of focused gaze, sort of concentrate on intention, which I'm guessing is not a coincidence. And you asked a poll question that our audience can see as well. But what part of people's business this kind of focused gaze might benefit most? And our audience is going to be taking a look at that. But I want to put that to you before we get into the other questions. I mean, what do you think the key areas of gain are for this kind of insight?
You can't solve a problem that you don't understand. And what we are presenting to our customers is that deep insight. When you're a production engineer on the plant floor, you're not there all the time. Now, what we are doing here is we are highlighting the issues. So essentially, the vision system is there all the time. And we're able to identify the issues that need attention of human beings who can actually take that insight and act on it. And that is the most fundamental shift that we're making happen by empowering those people with facts and information. I think that's a single thing.
Let me jump in on that. I mean, managers have been walking around with clipboards and stopwatches, for as long as there have been production lines. So is this vision sort of more of the same, but hyper focused and hyper automated, or is there some kind of conceptual shift in what this kind of hybrid automation brings to a human workforce?
There's a massive shift that's happening. So the basic example of the spreadsheet and clipboard is absolutely the baseline. But just stop and think about what you can do from an ergonomics perspective. Think about what you can do from figuring out how to optimize who's on your production line. So I'll give you a little example. Moneyball taught us that the batting lineup could be optimized. You could actually take the special skills of each player and deliver a significantly different result. Just the same people. Now, with the kind of data we're talking about, you can actually optimize the build on your line by taking the right people and putting them in the right places because they are good at certain things and not so good at other tasks. So you're really not asking me to be a pitcher and a hitter and a catcher. You're just saying you're a good pitcher, pitch well. And it's the same thing on the line. We can restructure how you run a plant, how you staff the plant, how you incent people on the plant, how do you keep them safe on the plant with this data.
Got you. Thank you. I mean, and following on from that line of thinking, I think you've mentioned that the emphasis here should be on augmenting the creativity, the flexibility that you have in human workers. I mean, that's the good thing about having a human workforce. But I mean, it strikes me as that's going to be tricky to do in such an automated setting. I mean, you've got the engineering problem, how you sort of deploy this and set this up, but then also just in terms of individual sensibilities. I mean, nobody likes a manager looking over their shoulder. So in deploying these systems in real factories, how is that introduction managed so that you genuinely sort of get a workforce on side and think, as you're telling them, how do you really persuade them, how do you get them on side with something like this? Because I imagine, as we've seen with the Amazon example, there will be some resistance.
Yeah, no, perfectly good question. So I think the first is a point you made earlier. There's always been a give and take in the relationships between companies and employees. My email is completely accessible to my employer, as is yours. That's just a given, right? So we've had measurement systems on our plant floor for 100 years now. So the notion of a measurement system is completely given. Now, I think what this does is highlight people's capabilities. And I'll give you an example to sort of make the point. We speak to what we call a brilliant outlier, the person on the plant floor who's capable of doing something unique. And in a white-collar job, you can tell that I'm a better engineer than somebody else. Now, the question is, on the floor, how do you tell? And the example is of that of a gentleman we found statistically in our numbers who was able to do a job faster than everybody else. And we asked ourselves, why is that happening? And the numbers are showing that. And we went down to the floor and looked. It turned out he was taking a rubber hose and sticking into the radiator to connect the two. And he would show up every day with a glass of soap water. He would dip the rubber hose in soap water and stick it in there. Everybody else was trying to take a rubber hose and stick it into the plastic, as you can imagine, much easier with soap water to eliminate the friction. Statistically, we could tell that. And so once we had the statistics, you go back and say, oh, Joe, tell me what you did. Why did you do that? And now suddenly you improved the standardized work process. And this idea goes across the entire world, every plant of mine. So this is fundamentally the kind of thing where you can celebrate human capability on the floor. So that's example one. Example two is that oftentimes when the customer calls in and said you did something wrong, or the OEM calls in and says something you did something wrong, there is no mechanism for the plant floor or the supplier to fight back and say, here's evidence to the contrary. And we've seen this time and time again, where every line associate wants to do their best and is proud of the quality of their work. And now we have the evidence to put in front of everybody saying, I did my job. There's an issue down the road, go fix it. And that just changes my perspective on life. And I think the third is we're painting much bigger than the first two. We're painting a picture where your job is safer because your improved capabilities means it's that much harder to replace it with a robot. So it really comes down to the most fundamental question, is my job safer or not? And we're enabling that.
And I mean, all of those are good, positive examples. Are there negative examples that you've had in introducing these systems, lessons that you've learned? In actual fact, maybe we could have done that more smoothly, or, advice now that you would give to clients installing this system?
Yeah, I think the most fundamental question is the management system punitive or supporting? Right? And I think that's the real asset. That's exactly right. And so we try and avoid customers who are punitive in their thinking. We actually look for customers who are progressive, who understand what this is, and we ask them to bring the line associates into the design process even as we're laying out the line. So it's completely transparent what's going on. Because this data is sitting on the plant floor, the line supervisor is seeing it. So by making it transparent and making them part of the journey, it just transforms their understanding. And in fact, we have cases where they come back, the line associate will go back to the line supervisor and say, I have an idea, can we test it out? And this is something else that we can do. We can literally, it's like A/B testing on an e-commerce website, right? You got 5% of the website that you're testing for revenue driving revenue. Now imagine that I can go to the plant floor and I can change on this station the tool from the right-hand side to the left-hand side because I believe as the line associate, I can do it better. You can actually run a 2-hour sample because I'm measuring everything. So for 2 hours, my rotation, run the new experiment. If it works, guess what? It becomes a standard. If it doesn't work, kill it. And so what we've now done is we've gone from Kaizens that happen maybe once a quarter, maybe once a year, to Kaizens happening every day. So what this means is continuous improvement is truly continuous. It is not about waiting for a scarce industrial engineering resource, but having 2,000 industrial engineers on the floor. Every one of those 2,000 line associates is now an industrial engineer. So you suddenly scale the thinking, you transform. This is what I mean by structured problem solving, touching everybody on the plant floor because you got the data.
Got you. Thank you. Let me just change subject slightly and bring in an audience question. We had Risika asked a question earlier, and I think she was picking up on some of the timeframes you were talking about. And you mentioned research work that you'd done 30 years ago that hadn't yet really had an impact. I mean, do you have any general thoughts about why there is such a delay before we're seeing the impact of these in industry?
Yeah, I do. So I think the beauty of where we are with AI and Drishti in particular is we are manipulating bits. Manipulating bits is far easier than trying to build a robotic hand where you're manipulating atoms. Because the electronic system has to work with a physical system that has all kinds of limitations. Just getting power density to be able to power a hand is a physical problem. It's an electromechanical problem. You need a higher capability motors. Running in pure software, computer vision as we are doing, it's a much easier problem. There's a reason why e-commerce on the ordering side is much easier than the delivery side. And so I believe that when you have bits talking to atoms, it's a harder problem than when you're talking about bits talking to bits. And that's why we see much more progress on the software side than we see in the physical and virtual sides.
Got you. And while we're talking about deployment, another member of the audience, well, actually more than one member of the audience, is interested in what the actual deployment and onboarding looks like when you take this new technology and put it into factories. We've got less than 2 minutes left, so maybe just one or two most important things that you need to do.
Yeah, it's actually deployment is trivial. It's a matter of hanging a camera and connecting it to power and Ethernet. And everything else happens in software. So that's the beauty of it. The second is we can have our streams running within 24 hours. The first visual stream comes off the floor instantly. The second value is we can have our cycle neural networks running literally within 2 or 3 days. So you know very quickly how your line is performing. It's almost like you're doing now process control on your line, knowing what the cycle time is, what the beat of the line is within a few days. It takes us a couple of weeks to get the more detailed in-cycle quality insights that we were talking about, the steps themselves, to be able to, in real time, tell the user or the line associate to go back and revisit an activity that you just performed to prevent any defects from going down the line. So it's we've now got to the point where we can do these first two steps very quickly, and the third still takes us a little time, but all these are very I would say very, very reasonable time periods given where the technology has moved.
Thank you. So we've got 30 seconds left. I'm going to ask you the question we've asked everyone. After that talk about sort of precision measurements and precision prediction, if you could go back to your March 2020 self and give yourself some advice to get you through the pandemic, what would it have been?
It would have been to have built my delivery systems for this in a world when I cannot see somebody, where I cannot actually be on the line. So what we've had to figure out, how do you deliver this at scale to people who've never seen this and can hang it up and make it easy? The deployment question, how do you make it easy? And we've solved that problem.
Thank you. Thank you, Prasad, for all that insight and for having an honest conversation about the pros and cons.
Thank you so much.